The billions and billions and billions of dollars it's going to require to update all the infrastructure, whether it's pumps, pipes, plants, it's not there. We don't have the developer base paying for all this that was put in 50 to 100 years ago that paid for it the first time. That's the challenge to getting this stuff to market. It's just educating people. It's getting people to reconsider what they've done in the past. Understand that there's limitations with anything you put in the ground.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Chris MacDonald, founder of CPM Pipelines. He's going to be telling us about pipeline rehabilitation systems, how the industry is evolving, what challenges there are, and what we might see in the future. So without any further ado, let's get into the episode. Welcome to the Pumps and Systems podcast. How are you doing today?
Good. Thanks for having me, Tom.
Yeah, absolutely. So before we start into our main topic, would you mind introducing yourself? So tell us a little about who you are, what you do, anything you would like to share with our listeners and viewers.
So my name is Chris MacDonald. I own a company called CPM Pipelines based in Phoenix, Arizona. So basically, we specialize in pressure pipe condition assessment and pressure pipe rehabilitation. My background goes back to the late 90s. I started in the industry, water wastewater industry, working for U.S. Pipe and Foundry back in the late 90s. Was in distribution for a long time before starting this business about 15 years ago, back in 2010. And we made a real focused effort to specialize in pressure pipe condition assessment, pressure pipe rehabilitation type stuff. Probably about 5 to 6 years ago, really started doing pressure pipe type rehab work, probably close to 13 years ago when we first brought flexible fabric type pipe rehab systems into the US market. So that's kind of what's led up to today as we scale the business nationally across US and Canada.
All right. Yeah. And so today we are going to be talking about pipeline rehabilitation systems. So could you give us kind of a brief, what exactly do we mean when we say pipeline rehabilitation systems? What are the 101 basics on this topic?
That's a great question. I have to remind myself oftentimes when we're having conversations with different consultants and clients that not everybody in the room has the same background and experience that we have with this. And also, even if they have it a little bit, we focus on it, 24 hours a day, 7 days a week, where they might just pop in and out for a specific project from time to time that they're looking at something like this. But pressure pipe rehab specifically is focused on the rehabilitation of existing infrastructure that's been in the ground. It could be water pipes, it could be wastewater pipes, it could be high temperature pipes, it could be chemicals, industrial type stuff. So we really have a broad spectrum of what we do, but we're trying to identify deficiencies in those existing buried piping systems and then come to the table with typically trenchless solutions. So there's most of the rehabilitation type solutions are going to be trenchless. So you're going to open up like a pit several thousand feet apart, clean the existing pipe, do condition assessment like on the existing pipe, determine where the deficiencies are, and then put rehabilitation systems inside of those pipes. So what's really important if you kind of start back at the beginning is there's different types of rehabilitation systems depending on the type of pipe, what you're trying to accomplish, the condition of the existing pipe. So just as an example, you have AWWA, or the American Water Works Association, has 4 classifications for rehab. There's class 1, class 2 and 3, and class 4. So class 1 is basically just a spray applied product, typically that's going to be like an epoxy or a cementitious type product that just has to bond to the interior of the pipe, and it's looking to basically provide some sort of corrosion resistance or barrier between the media and the pipeline. So a class 2 or 3 is a semi-structural system that's meant to bridge holes and gaps inside the existing pipe. One, like a class 2, bonds to the pipe. A class 3 doesn't have to bond to a pipe, but those are pretty typical for pressure pipe applications for rehabilitation. So our specific system is considered a class 3, which means it has to be semi-structural, it has to be rigid, it has to be self-supporting, which means it has to stay open when there's no pressure on it and support itself and act like a pipe. And it has to have the ability to bridge holes and gaps as they occur from like corrosion inside of an existing pipe. So that's ideally suited for like a pressure pipe application. A class 4 system is similar in that you pull it into the existing pipe somehow. It could be a solid wall pipe, it could be a cured in place type pipe that has epoxies and resins that you pull in uncured, you open it up and you cure it to make it rigid. So those types of pipes are meant for gravity sewers, not something that somebody using pumps would typically look at. But the industry as a whole, you have a lot of people that have a lot of experience with gravity sewer pipes. And they're very familiar with gravity sewer rehab systems. So it's important to kind of talk, if you start at the beginning, about the differences. So with a gravity sewer, you have to use a class 4 structural system. So class 4 structural system basically means that that pipe is meant to fully replace the existing pipe. So why do you have to have that with a gravity system and you don't necessarily with a pressure system? Gravity systems are designed specifically, if you look at Spangler's equation that you use to design pressure pipes and gravity pipes, gravity system pipes are designed based on external loads and forces. So they rely heavily on soil support to keep them round and open and flowing from a gravity perspective because there's no pressure inside pushing out against the wall. Pressure pipes, on the other hand, are inherently the wall stiffness or the wall thickness provides all that hoop strength required to contain the pressure. So with a gravity system pipe, when those types of pipes fail, you have to put something in that replaces the structure because that's what's failed is the structural capability of the gravity sewer pipe. With a pressure pipe, if it starts to have like leaks and holes or gaps and joints, things like that, you don't have to fix the pipe structurally. The pipe is still structurally sound and intact. It just might have a pinhole or a joint that's bad. So that's why you don't have to put a class 4 structural system inside of a pressure pipe when you try to rehab it. You simply have to put a class 3 semi-structural lining system inside of it. So back to kind of how these different systems get put in place. It's usually you fold it up or it's not cured out, or there's some way that pipe is smaller diameter than the host pipe, and then you drag or pull or invert that pipe into the existing pipe to put a new pipe inside of the old existing pipe to either keep it from leaking or structurally rehabilitate it. So that's kind of the basics of pressure pipe, just in a really quick, short summary, just kind of what the different types are, what the differences are between like a class 3 and a class 4, which is very important when you're talking about pipe rehab.
Okay, yeah, thank you for the primer because I definitely did not know all of that, and now I do. So thank you.
Most people in the industry don't. It's something we typically start with because if you don't kind of start with the differences between pressure and gravity, oftentimes you'll have people just jump right to, well, let's just put a class 4 system in. But you have to understand the differences of why you use one versus the other in different situations to really be able to make a educated decision on how to approach your different rehab projects.
That makes sense. All right. So moving on to the pipeline rehabilitation industry as a whole. So how is that industry evolving right now? And what kind of major shifts are you seeing compared to like 5 or 10 years ago?
So back to kind of gravity and pressure, right? So the gravity sewer side started probably in the 70s. So different companies started looking at ways to rehabilitate gravity sewer systems. And why it started there was because the access was much better. So basically, you had a manhole that created access to the piping system. The pipe was mostly empty because it flowed by gravity, so you didn't have it full of media and pressurized all the time. So you had much better access. So the industry evolved pretty quickly through the 70s and 80s to create systems to both inspect those types of pipes with camera systems because you can see the defects you're looking for with a camera or a video of some type. And then they came up with ways that they could basically create a pipe inside the existing pipe using different resins and felt and fiberglass eventually and different components that would allow them to basically flip a pipe inside the new pipe and then open it up and cure it out rigid to where it would replace the existing pipe. So that industry has matured over the past 50 plus years and become sort of commonplace in the industry. There's still a lot of people, though, that haven't used those systems, cameras, cured in place systems, things like that, to this day. And it really kind of surprises me sometimes. We have conversations with clients and we'll be talking about the new stuff related to pressure, and we'll kind of backtrack and start talking about the gravity sewer stuff that they haven't even used it in the past. So there's still opportunities on that side of the business. But what's really started to evolve over the past probably 10 to 15 years is the pressure side. So we went from basically just trying to pull a pipe into an existing pipe. So you take a polyethylene pipe that's much smaller than the original pipe, you pull it into that pipe, and then you have a new polyethylene pipe, for example, inside of the old pipe. Then they started looking at different bursting equipment. So you could actually take a burst head or a splitter head that you pulled into the pipe, which actually opens the pipe up and then allows you to pull a larger, like polyethylene pipe, for example, in behind it so you don't lose so much capacity. Because the initial technologies, you ended up losing a lot of capacity inside the pipe. So as that continued to evolve, you started to see flexible systems. So you started to see initially what was called the loose fit flexible fabric system. Real good idea. You take the pipe, you manufacture a round, you flatten the pipe, you fold the pipe in half, you pull it into the existing pipe, and you open it back up with air. So that was a really great solution for probably the last 10, 15 years. But the limitation was you left a lot of annular space inside the existing pipe. So you lost a lot of capacity. So if you're looking at it from like a pump perspective, right? Because I know a lot of your audience probably is big into pumps. You've got these pumps set up to push so much media through a pipe based on the internal dimensions of the pipe. If you pull a loose fit system into that, you lose a lot of that capacity. So it's further evolved in the past probably 10 years to now have available a large range of sizes, 2-inch all the way up to 64-inch, that's actually a close fit, flexible fabric, reinforced pressure pipe system. As it's evolved, each new system has kind of addressed a lot of the challenges and problems with the old systems. So for example, like the initial gravity sewer systems, you can typically do small diameters, short runs. So that's obviously gotten much, much bigger. You can do much bigger diameters, a little bit longer, but you're still kind of limited because of how the systems work as to how far you can pull them. And because of how they cure, you can't go around bends. So same thing with pressure pipes. A lot of the original systems, you couldn't pull through bends. You just had to go straight. So if you had a river crossing or a road crossing or a bridge deck crossing that went up and over, you were pretty limited. You had to kind of get in closer to where the bends were, take a lot more pipe out, remove it before you could rehab that straight shot or straight section. So with the introduction of these flexible systems, it started allowing you to go out much, much further distances. You could pull through most bends like 45s, 22s, 11.5-degree bends, things like that. So that's really evolved. And then with the rehab systems evolving, you're starting to see the condition assessment stuff evolve with it. So sort of the same things happen. You initially had cameras to look at gravity sewer pipes. With the pressure pipe side, a lot of people focused on pre-stressed concrete cylinder pipes and wire breaks, which was about the only tech that people were really looking at and focused on. and the companies were chasing after. But now there's inspection systems that can look at all types of pipes. So you can actually look at the pipe wall thicknesses for metallic pipes. You can see where stress is created in plastic pipes with inspection technology now. So as that's evolved, it's given us more opportunities to go to like a find and fix scenario, which is much like gravity sewers. So gravity sewers, you wouldn't just start putting cured in place rehab lining systems into without inspecting first, and that's become common. Pressure pipe, we're still coming along. So we're still putting rehab solutions and trenchless solutions into pressure pipes a lot of times without a lot of good information. But we're starting to be able to really pinpoint the locations that need addressed. So you don't overspend, you don't underspend, and you don't spend too soon or too late. Like we just recently, like for example, we had a client we've been working with for probably 10 or 15 years who had a major main break a couple weekends ago. We've talked to them about inspecting that pipe for a long time or similar pipes throughout their system. It got to a point where one of them catastrophically failed. They've had over 100,000 people out of water. So it's a really unfortunate event. It couldn't be foreseen really, but the technologies that are out there will allow clients now to better locate those types of situations before they become emergencies and then rehabilitate those pipes proactively instead of reactively. So that's really what's starting to evolve. People are starting to take the same proactive approach to pressure pipes that they have always not always have taken, but initially started taking with gravity sewer pipes, which is allowing them to better manage their system, make it more sustainable. The solutions are more environmentally friendly now. It's more cost efficient, it's more cost effective. So there's just a lot of things that are happening within the industry that have been really slow to evolve, especially on the water wastewater side with like utilities. You'll see it move quicker on the industrial side, chemical side, stuff like that, because they have more interest in being more cost efficient quicker and they can make decisions quicker. But we're slowly starting to see the municipal side evolve as well. So that's really what's kind of evolving and shifting over time is just how agencies approach their systems and their assets. Like asset management's becoming a bigger thing. Pipeline condition assessment's becoming a much bigger thing. Clients are starting to move away from just desktop approaches, which are very sophisticated in a lot of cases, taking like pipe type, pipe material, age, break rate, stuff like that, to analyze and prioritize which pipes they think are most likely to fail and have the highest consequence. But until they capture that actual field data on that specific pipe, it's hard to guess where the problems are. So that's what's really starting to evolve, especially in the past probably 10 years. And even the last 5 years, we're really seeing a shift across the industry with those types of things.
Yeah, and when it comes to evaluating rehabilitation approaches, what would you say are some of the most important technical considerations that operators, engineers, that they're focused on right now?
You have to look at things like pipeline geometry. You have to look at access. You have to look at if there's different structures overhead that you're going to have to account for. You have to look at what type of pipe it is, what diameter the pipe is. So certain solutions only go up to certain sizes. Like, for example, a loose fit fabric system, despite all the benefits to it, only goes up to about 18-inch actual diameter, where a close fit flexible fabric system can go all the way up to 64-inch because of the different limit states it operates in within the pipe, either independent or in conjunction with the host pipe. You also have to look at things like condition, right? So you want to really know as much as you can about the pipe's condition before you make a decision as to how to rehab it. We had a really interesting project recently on a force main inspection that we performed for a client. And we were able to see that the northern 5,000 feet of pipe, despite the fact that it was in poor condition, was in much better condition than the southern 5,000 feet. And we were able to even look so close as to see which specific 20-foot sections of pipe were the worst and most highly deteriorated pipes throughout the entire alignment. So it gives the client the option to then evaluate which solutions to use at a really high resolution so they can decide if they want to just do some spot repairs, if they want to rehab longer sections of pipe, what the access looks like for each section that they need to fix. Like there might be a section here that was poor, but it's underneath a 6-lane highway. So you can't just go in and put a clamp around that and fix it. You're going to have to pull some sort of system into place to rehab it from end to end without having to dig the entire freeway up or jack and bore a new pipe under the freeway. So it just limits the number of solutions that are out there, but there are solutions out there to do that. So you have to really take a lot of these different factors into account to decide which solution makes the most sense. Like, for example, a cured in place system is great if you've got pipe that's already collapsing or already structurally deficient, but it can't go very long distances and it can't pull through bends. So that limits where you can use that. It's a great solution. Same thing with polyethylene. It can pull long distances, but the pipe has to be virtually straight in order to pull the polyethylene through the pipe. So if you have a bend, you have to dig it up at every location. You have a bend and stop and put pipe back in. So it limits what you can do. So you have to really approach each technology, not from a cost of the actual pipe or the technology, but a total overall installed cost for the project, because there's differences in schedules, how much time it takes to install each system, how much time it takes to procure and ship each system. So there's all these different factors that come into play on every single project you're going to look at. So those are some of the different, factors that you should consider when you're trying to determine which solution makes the most sense for you.
So let's say that a new rehabilitation technology has entered the market. So what do you think are some of the biggest challenges with adopting and implementing that technology?
The establishment. I think most people can probably figure out what that means. The biggest challenge with anything new is you're up against everything else that was out there prior to you, whether it was good or bad. So you're really up against the establishment. All the companies out there, whether it's a contractor, a municipal agency, a consulting company similar to ours that actually brings new technologies to the market, until you convince them it's something worth looking at, it's not going to go anywhere. So you're up against what they're already using and doing. And most people just are slow to change or adopt something new, even if it's not working, right? Like a good example of this, you'll get a call and somebody will say, hey, we want to take a look at rehabbing this steel pipe. Okay, we've got a great solution for that. It's a long distance, it's got bends, perfect. We have the solution for that. What's your design life? Well, our design life is very conservatively based on our hydrostatic design basis, about 50 years. And that's based on the theoretical or the tensile modulus, long-term tensile modulus properties of the fabric that we use, right? So you'll get through this conversation. It'll start moving towards, yeah, let's seriously consider rehabbing this pipe. And then somewhere along the way, somebody will say, well, the original pipe had a 100-year design life, and the owner's really interested. They want something with a 100-year design life. And then you have to just put it back on them and say, how old's the pipe that we're looking to rehabilitate right now? The steel pipe we're looking to fix, how old is it? Well, it's 40 years old. Okay, wait a minute. There's a dot that's not connecting here. You want us to give you a 100-year design life. The product you put in the first time had a 100-year design life and lasted 40 years. Why are you expecting a 100-year design life when what you've done for the last 40 years didn't last 100? But you're still up against that same mindset and thought process. They're like, well, yeah, but we got a 100-year design life from them when we put it in. It's like, okay, well, I can tell you it'll last 100 years. If it does or doesn't, is that important? So you just have to kind of change how people think about things and approach, and you have to kind of put it back on them with what they're doing currently so that they can start sort of seeing it, so you can start getting them to start thinking about adopting something new. So that's a huge challenge with anything new, and why we decided as a company to only take on new technologies. I still can't give you a good answer because it's the most impossible, hardest, most difficult thing to do in this industry, but we've still taken it on because we see huge value in that. So It's challenging, but it's necessary because the state of the current infrastructure, you can't, the billions and billions and billions of dollars it's going to require to update all the infrastructure, whether it's pumps, pipes, plants, it's not there. We don't have the developer base paying for all this that was put in 50 to 100 years ago that paid for it the first time. It's having to come out of rates and the rate payers and the people using the systems, right? So that's the challenge to getting this stuff to market. It's just educating people. It's getting people to reconsider what they've done in the past. Understand that there's limitations with anything you put in the ground, right? If you choose to put metallic pipe in the ground, you're going to be fighting corrosion the entire time it's operating. If you choose to put polymer pipes in the ground or plastic pipes of some type in the ground, you're going to be fighting stress on the pipe walls. You're going to be fighting bury conditions. You're going to be fighting how the contractor put it in the first day that caused all this extra stress in the wall of the pipe that eventually causes it to fail. We have all these tests. Everybody wants to talk about tests. So people have you jump through all these hoops, perform all these tests, but are the tests really indicative of how that system performs in the field? Most of the time, they are not. If you look at how metallic pipes are tested or do long-term testing for design basis, they don't take corrosion into account. If you look at plastic pipes and their long-term design basis, they take pressure and cyclic pressure into account, but they don't take stress in the pipe wall that can happen during installation. So the things that actually cause rehab lining systems to fail, new pressure pipe systems to fail, aren't really properly incorporated into the test. And that is what also causes some challenges to bringing something new to the table, because they're not familiar yet with how these systems actually would fail in real life. So that causes a pause, despite the fact that systems that they've already put in, assuming a 100-year design life, in some cases are lasting 20 years.
Yeah, and looking ahead, what technical trends do you think are going to have the biggest impacts on pipeline rehabilitation over, let's say, the next decade or so?
I think you're going to continue to see the introduction of these flexible fabric systems. It's just really starting to get some momentum. But most of the stuff we're probably going to see is going to come out of places like Australia, Europe, Asia, Canada, because those are the places that are really interested in developing new stuff. The partnership we have with our main manufacturer out of Asia, when COVID happened and kind of shut the whole world down, everybody else kind of went on pause. They started investing and they started creating new solutions and new technologies to fixing infrastructure. Same thing with inspection type companies out of Europe and Asia. A lot of these companies have continued to develop their technologies where we don't see a lot of that happening here in the US. We see a lot of things like, aerospace and things like that here in the US. So there's specific industries here that we've really invested in over time. But when it comes to like infrastructure type stuff, you just don't see the same investments here that you see around the world in different places. So it's really hard to say what that's going to look like 5 years or 10 years from now. What I try to encourage our clients to do is just account for there being new things out there, and let's try to design and build our systems around what might come, which a lot of times that means just making sure pipelines are fully open. You don't have a lot of restrictions or valves in them that you would have a challenge getting a new technology or a new tool through. Same thing with rehab solutions. Don't use hard radius bends in your new piping systems, because if you use long radius bends or 45s instead of 90s to make a radius, it's going to make it a lot more open to new technologies in the future that could potentially get through their system to either inspect or rehab it. So you have to kind of think ahead to what might be coming so you can build your systems around what technologies could be out there potentially to inspect and rehab your system in the future. But what's coming, I don't know.
So before we wrap things up, is there anything else you'd like to share with us, or any final thoughts you want to leave us with?
I think everybody has to just be realistic about how their systems operate, how their piping works, how their pump systems work. You have to take the lessons you learned and apply them to your new construction type projects. I think that's so important that you can see all these potential problems you're having and not adjust to them. If you look at like one of the big industry conferences out there, which is our pipelines conference, you go to the pipelines conference that's with ASCE, UESI, and a lot of the conference is talking about metallic pipes and corrosion and how to address corrosion or how to inspect for corrosion. But a lot of the same users of those metallic pipes, municipalities, utilities, things like that, they'll spend all this time and money trying to figure out how to address that with their piping systems. At the same time, they won't consider like a polymer type material as an alternative because the metallic pipe industry, which is the establishment, has made them think that the polymer pipe industry is bad. Well, it's not. It has limitations just like metallic pipes do, but it does solve the one critical problem metallic pipes have, which is corrosion. There's other issues that you have to think about, like installation and how joints go together and how backfill's compacted and these sorts of things, but you don't have the same issues with corrosion. So how big of a problem has corrosion been throughout your system versus how big of an issue would like unnecessary stress in the pipe wall be if you install it properly and inspect it from day one? So I think you have to keep an open mind when it comes to new tech, new pipe materials. There's just a lot of fear that's put out by the establishment. It doesn't matter if it's pipe or pumps or whatever it is, like people aren't coming up with new solutions that they think are going to be worse than the existing solutions. So you just have to kind of take the things you hear from different people in the industry, understanding their motives. So, I think keep an open mind, understand if somebody's telling you something bad about somebody else's product, where that's coming from, and do your own research, do your own engineering, do your own design work. So you have to just kind of consider the source when you're working on new things or looking or considering new things. And if the person that's telling you something new is bad has some sort of financial motive, to be telling you that.
Okay, so keep an open mind and do your research.
Exactly.
All right. Okay. Anything else you want to say before we wrap up?
No, this has been great. I appreciate you giving me some time to come on your show and talk about some of the things going on in our business, and hopefully people will find it helpful.
Absolutely. I definitely think they will. I definitely learned a lot. So yeah, thank you so much for taking the time to be here. We really appreciate it.
Awesome. Thanks.
Huge thanks to Chris for taking the time to speak with us today about pipeline rehabilitation systems. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube page to see the full video version. That's going to do it for this episode. Thank you so much for listening or watching, and we will see you next time.